Engineering and Sciences 2020. I'm happy to present before you our research topic title, Investigation of Adsorption Behavior of Acetone Vapour towards a Surface Plasmon Resonance Sensor Layer using Adsorption isotherm models. These are the authors that contributed to the realization of this great work. First, the absorption. It is just a process in which atoms or molecules move from a bulk paste onto a solid or liquid surface. Usually, the materials that absorb the analyte is what we call adsorbent, and the analyte is what we call adsorbate. And this interaction mechanism is being described by so many different isotherm models. But the most prominent one are these two, that is the Langmuir model and the Freundlich model. And these are the two types of adsorption behavior. We have the physical adsorption and the chemical adsorption process. So usually in the case of these two isotherm models, actually for us to judge which one is the best, usually we judge in terms of the R-square value and the error value. We expect the R-square value to be large, and we expect that of the error to be the smallest possible value, Then in this case, we were going to apply this adsorption behavior to describe the interaction mechanism that happens on the surface of the Surface Plasmon resonance sensor layer. This is just the illustration of a typical Surface Plasmon resonance sensor. As we can see, we have in this figure one, we have the plasmonic material, which is gold in this case. We have actin sensor layer, which is a ternary composite that comprises of reduced graphene oxide, chitosan, and polyaniline materials. This is the acetone vapour that is being adsorbed on the surface of this ternary sensor layer. In this case, we use these models. We use both the linearized form and the non-linearized form to just describe this behavior. And from there, we also use this Freundlich model to see whether the adsorption behavior is chemical-based or physical adsorption process. By having n less than 1, then we will judge that yes, it is a physical adsorption. So I mean, it is chemical adsorption. In this case, for this isotherm models, these are the definition. This is the definition of the parameters used, and for the adsorption evaluation also, we use this data in table 2, which is extracted from the experimental measurement of the ternary-based SPR angle shift due to various concentration of acetone vapour from 0.5 to 5 ppm. So from here, we were able to come up with this table 2, that contains the binding parameters of all the two different isotherm models in both non-linearized and linearized format. In this case, if we can have a look at this 4 different formats, we'll come to the conclusion that this Freundlich model, the non-linearized one, is the one that features the highest R-square value, and at the same time also shows the smallest value of error parameters. So in this case, we will conclude that yes, even in the case of SPR sensing, we can make use of these absorption isotherm models to describe the interactions between the sensor layer and the analyte, which not only acetone vapour, but we can extend this studies to any other analyte that happens to be adsorbed on the surface of SPR sensing layer. And also from here, we'll be able to come to the conclusion that we can also make use of these adsorption isotherm models to know which kind of behavior happens, whether it is physical adsorption process or chemical adsorption process. Also, we will also understand the suitability of a particular isotherm models to depends on the properties of the SPR sensor layer and the analyte, because what makes the analyte or what makes model to fit better depends on the type of the material as well as that of the analyte. Also, in the case of this SPR sensor layer, we also tried to investigate whether that sensor layer is reversible and refutable. From this figure 2, we can see that as soon as we cease the supply of this analyte, that is acetone Vapour in this case, the response of this sensor changed to the initial state, as we can see. In this case, we conducted the experiment using 5 ppm acetone Vapour. These are 2 cycles. As we can see, this is the first cycle and this is the second cycle, and the recovery is almost 100%, which shows the excellent behavior of this sensor layer. And at the same time, with the help of these isotherm models, we were able to come up with a very clear description of the absorption behavior that happens on the surface. So this is all I have for you. If you have any question, you can just pass that question to the right channel. Thank you so much. Bye.